Hello peoples. Have you ever thought to yourself like, hey, I have a cool car, but somehow it doesn't sound like I expected it to be when I bought it, you know? Like all these people on cool in the internet, their cars sound cool and they have so much more power than my car has. And yeah, then you open the bonnet and bam! All these weird factory pipes, all these noise cancellation, frequency dampers, everything. Huge airbox. Oh my god. Not good. We're gonna fix it today, and I'm gonna show you how you can do some magic on the computer, use some plastic, make it heat it up, and then you get this beautiful self-made intake. Okay, so the first step is going to be obviously to scan the engine bay. For that, you use any kind of 3D scanner you might be able to get access to. Either you buy your own, there's cheaper ones, like Creality has some cheaper options, but you can get some fancier ones. I used for the purpose of scanning this, because that's what I had access to, what I could borrow, was a Creality
Otter.
Yeah, with that, I scanned the whole engine bay since I had some different ideas what I want to do as well, and on the front here. But if you have some area, whatever you want to do, for example, is intake, you should scan this area because you want to know the location of your throttle body and then how much room you have. You want to scan as detailed as possible. Obviously, you would take your intake off to scan it. Yeah, you want to scan any areas like that. I can show it easily, which might get in contact, which might limit your space and determine where you need to make your bends and how far you can go. You want to make sure that you scan these areas. And for example, this charcoal canister here, I can't put it down low too much. I have this sensor here, which I need to, build around, but also be not too far away so I can connect my airlines. And these are all the limitations that you have. If you really want to be fancy, you can also scan whatever accessories you want to attach to your intake pipe in the end. For example, you could scan, or just, since it's a simple shape, just redesign this filter in your CAD program. So you can set it to the place you want it to be and then make the connection to the pipe. That's the basic where you start. You don't need anything fancy. You don't need a scanner that costs €1 million, $1 million or yen or whatever currency you have. You can even just borrow one like I did. Scanning's pretty easy. I wouldn't put that in this video too much because every scanner is slightly different. So I guess the best would be to pick the tutorial for whatever scanner you have. There's plenty out there. So yeah, what you want to do is there's different settings in the end. So even if you do the scan, do it nice and slow, get in all the areas and check on your display or your laptop that you get the scan deep enough into all the places where you want it to be, and not just scan on top here, or you'll only get the top of the manifold. And you want to get the whole intake and all of this heater hose and everything. You want everything scanned, like you can see in my scan here. This scan is even, it's not a fancy scan, but it has the most basic information of what you need for your project. And once you've got that scan done, you can take your computer back inside and start on the 3D designing. And that's what we're gonna do now. Let's go. Okay guys, once you've got your scan done, you can add your scan, of course, in your scanning software. You're gonna export it as a STL or OBJ file, or whatever your scanner program allows you to do. I mostly like to use STL because that's just what I'm always use. And you go insert, what's the English translation going to be? Insert mesh, I guess. And then you can insert your 3D scan. As you can see, I scanned the whole front of the car. And if you scan it at first, it's going to be like that whenever you hover your mouse over it, it's going to highlight it. It's going to make working with it really slow. So what you can do, what I like to do, is go right click on your scan and then choose selectable, non-selectable. because once you positioned your scan, or you can do that first, because then the whole moving around is going to be a bit quicker. This scan is still pretty big. Like I made the, as you can see, the size of the triangles way too small. I could have done a way more rough scan and it would have been enough. That's what you can do to improve the performance in your program a little bit, also on lower powered computers. But if you have some patience, it's fine. If you then import your file, you can of course show your normal plane. And as you can see, I moved the scan to have the intake, the part that I'm looking for, that I'm mostly interested in. I put that on my XYZ 0 point, because that's what I'm working off of. This is the most important point for me. So instead of just importing the scan and then trying to get my planes somewhere where I can match this spot, I just moved my scan with the most important point. If you want to do a headlight, you're going to move the headlight over to your 0 point. Whatever you have, get a point that's important for your work that you want to do and set that as your 0 point. That makes just your life a lot easier later. And if you look at the scan, you can see it didn't scan all the way down into the engine bay. That's just how the scanner does. I could have done a better job with this scan, or could have played around with the settings, but I also did that at a pretty bright day, so that's not the best for these scanners. Always depends on but of course if your scanner is a bit cheaper, the cheaper the scanner gets, the more difficulties it's going to have with sunlight. But it still worked out well, and it's got all the important places. It's got the metal, or the sheet metal here for the what's called the fender here, the inner fender, and the frame rail down here, and I have the top of my radiator, and most importantly I have my radiator hose. That's what we talked about before. As you can see, my radiator hose here, what I want to work around. And basically for making this kind of intake pipe, it's pretty easy. Basically, if I show you the sketches I used, it's not much. As you can see, we have one sketch that matches the intake here, and also as you can see, this scan is also pretty rough here. You can play around with your scan settings to get it even better. This was also one of my first tries with this new scanner. And then basically for an intake, the function you're going to use is sweeping, or you can also use it in the shape, in this menu. Sweeping, or I don't know how to translate this one, but I guess if you have Fusion, it's going to be like that. If you have a different CAD program, but if you are in Fusion 360, which I can recommend since it's the cheapest of the commercially available programs, or like the most common ones where you can find a lot of documentation online as well. So I recommend Fusion. It's easy to use and very convenient. I started off with CATIA, but it feels a bit more outdated from how all the UI looks. So I'm quite pleased with Fusion. For a really basic explanation, if you just want to make a pipe with a constant diameter, you can use this sweeping function. However, my inlet is going to be different diameter as my outlet. So I made my sketches here, and so I used this function here. I'm not sure how to translate it, but this basically allows you to say, I want to connect this sketch with this sketch via this middle center line. And then what you get out of that is this pipe. You can see, can make it fit your engine bay. I could see this is exactly the clearance that we saw in the finished product on the car. And then you can extrude this outwards, because for now this is just a basically thickness-less object. It's just like doesn't have any thickness, it's just basically a line. So you can extrude it outwards, make it thicker, give it a thickness here. And once we do that, obviously we're gonna get what I showed you here. We're gonna get this. I also added some more features. As you can see, I added some things down here so the filter attaches easier and doesn't slip off. I added some cutouts on the sides, and as you can see, I reduced the diameter here a bit, so this part becomes a little bit flexible when you want to slide it over the throttle body, and you can attach your clamp here. I added this little bevel, do you call it a bevel? So the hose clamp doesn't slip off towards the throttle body. And these are just some features that you can add if you want to. As you can see, for this model, let's turn off the sketches. I even added some fancy golf ball structure, which of course can be debated if it has any use or not, but I just played around and tried something out. For example, here I added my logo, and I added this, what I told you before. Here, this attachment point for the fittings, and here I put in a 1/8 BSP thread, because that is a common thread that you can get for these kind of hose ends. So I integrated that in my print directly, because mostly if you print that, you can just screw in your fitting here, because obviously it's an intake, it's gonna have some vacuum, it's gonna have some air flowing through it, but it's not going to have any like high pressures or water or anything significant flowing through it where you need this to be 100% sealed. So by just printing it, and you need to make sure that you select that it actually models these, because in Fusion you can put in a thread and only mark it as a thread, or actually have it model the thread in 3D, like you can see here. This is the modeled version. So yeah, plastic is quite forgiving. If you print it, you can easily attach your hose end in there. And yeah, that's basically the process. If you have your part finished, you can go to export and export it in whatever file you need. For example, I always like to use STL, because STL is, yeah, for most 3D printing programs, the most compatible. If you want to send it to some online printing services, sometimes step files can work as well, but I think, at least from my experience, also most online printing services work with STLs. Yeah, STL is basically a mesh, a 3D mesh. So you have all these little points, these triangles. As you can see, there's a point here, a point here, a point here, and then it connects them to be a closed plane. And then it adds these through all of your points, because the scanner, what the scanner connects or the scanner detects is a point cloud. And if you then in your scanning program convert it into a STL file, it basically makes a mesh out of all these points, connects them, and then you get this. And the same is what you use for your 3D printing. You also make this kind of mesh file as the STL, which then the 3D program, Cura or whatever you're using, can convert into a G-code depending on your printing settings. And that's also what the printing services do. And yeah, quickly about 3D printing, you don't need a fancy printer. Obviously this one might be a bit small, but like this intake pipe that I designed could be printed on a Ender 2 size printer. And for filament in all my videos, I always recommend ABS. Here it's ABS. There's also filaments called like ABS Plus or something like that. Here this one is called ABS Plus HS for high speed. You need to find out what you like the most. There's ABS, there's ASA, there's PTG as like the, I would say the three cheap or like affordable but durable filaments that I would use for automotive applications. I have just always used ABS and I've always had great results. Even the intake has had zero deformation. Obviously, if something is connected to a more hot part of the engine, maybe ABS would come to its limits. I think ASA is a bit more heat resistant, but ABS is plenty and it prints fairly easy once you figured out your printing settings without any glue. As you can see, I built a little enclosure for my printer, and I have this how do you say, powder coated PEI plate. They work perfectly, and once you got your printing settings dialed for that, I can really recommend ABS if you have something which is not, how do you say, not in any warm place in your engine. TPU can be a really nice filament as well if you want to print something more flexible. That would also be a recommendation if you ever want to design something. For example, for the intake, this wouldn't be a good solution at all, because the intake should be a bit more rigid and more heat resistant since it's close to the engine. But for example, I printed some bushings already with TPU, which worked great, so this could be a solution for you as well. Apart from that, I recommend ABS or ASA, or if you have a fancy printer even, you can use like fiber infused filaments, like carbon fiber filaments or something like Bamboo Lab offers. And yeah, so much about the filaments. Let's go back to the program and show you some more details. If you think that especially if you zoom out, you feel like, oh, why is it becoming all black? This can be a setting in your visuals. So because this, as you can see on your print, it shows you all the connections. Like for example, there's a like rounding here, but even though these are tangents, I think it's the word, it still shows you these lines. This is just a setting. You can turn it off easily here. You can say I just want to have it smoothly displayed, then it basically doesn't show you all these lines and in between the points. Then it's a lot more pleasant to use. You can also play around with whatever setting you like and find the perfect one for you. But yeah, this is the basics. As you can see now, I turned on that you also see the invisible lines, so now you can actually see the golf ball structure that I modeled into my intake, but it's a bit unpleasant to see, so I like to go with only shadows. Either with shadows with visible corners or just shadows, so then you get a more pleasant look to your scan. And one thing to watch out for as well is that, as you can see, the headlight, which is just a glass lens, the scanner can't pick up see-through objects like this headlight. You can see in some corners it picked it up a little bit, but it got really rough, and the scanner just doesn't like reflecting surfaces. On this headlight, you can see I just took a tissue and put it over it. The scanner was able to pick that up perfectly, but everywhere, also here, the side in the indicators, which are also reflecting and see-through, the scanner doesn't like those, so you need to watch out and find a way. There's like scanning sprays, which, for example, you could have sprayed the headlight with a scanning spray, which gives it like a matte finish. These scanning sprays you can later just wipe off. They work really well, but for me, this wasn't an important point in my scan. I just wanted to try out and get the whole car, the whole front, to also later design a grille for the front, but I didn't need the lens for that, so I didn't bother about that. And yeah, with that you're done. As you can see, I didn't bother modeling the air filter because I could just see and hold it in the car and see that this was plenty of space for it to mount. Yeah, let's see how it looks finished on the car. And that's it. Once you're done, once you got your intake printed out or whatever part you were doing, you can install it, connect all your lines. That's the cool part about the DIY of that. Whatever you make, you can make it to fit your application especially. For example, I wanted to keep all the factory lines and connections accessible. So I, as you saw in my design, added these bungs here to connect the AC solenoid and the other idle air solenoid here. We have these two air lines going there. I made the connection fit my whatever filter I had perfectly. I made it up here. I decided to go and keep this rubber seal in here, so I designed my part to fit around this. If you use some other kind of material or have a different solution to bolt on or something onto your manifold, that's for you freely to choose. And you can enjoy some nice noises and be proud that you made your own cool intake for your car or whatever you wanted to design. And if you have an 86 and you don't have, or you don't want to do it yourself, or you don't have the accessibility for a 3D printer or a 3D scanner, if you want, this 3D file to print this yourself is available on my Etsy store, as well as I'm selling this full intake kit with the filter and the pipe and the connections, or some plugs if you don't want to use those. It's all printed in MJF professionally, and yeah, if you want, check out my Etsy store. I'd be really happy about that. And if not, I'd say thank you for watching. Have fun the DIY way, and maybe if you want, see you in the next video. Bye bye.